Okay, so we're going to get started talking about exceptions and assertions. So the big points in this, number one, implementing try, catch, finally blocks, how exceptions are handled locally in methods, and then how they're passed on to other methods. And then the last, distinguishing between checked and unchecked exceptions. And last, assertions, which we'll mention. Okay, so an exception is an error condition. Something goes wrong as the program runs. The typical terminology for that, we say the exception is thrown. So anytime something goes wrong in your code, an exception gets thrown. And as we'll see, it can either be handled locally in that method, or if not, it'll get passed along to the method that called the method where the exception handled, and then get called further back, ultimately to the main method. Okay, so here's an example. We have a scanner object, and we ask to enter a number. If we enter a number, that's not an integer, right? We can't use this next int method to return an int to number here. So we'll see how that plays out. Let's do our code. We'll make a new class. Let's call it exceptions demo. Okay, we'll give it a main method. And we'll import the scanner class. Okay, so then this code will take and just lift it right in there. So it'll create the new scanner object, it'll ask for an integer, and then if it works correctly, we'll print out you entered such and such value. You entered plus number. Okay, so let's run this. We'll do it once through the normal time, make sure it works correctly. Okay, we'll enter an integer 3. You entered 3. Wonderful. Now, if we enter in some invalid value, like say 3.1, that can't be turned into an int without typecasting, boom, we get this. We get the dreaded input mismatch exception. And this is a stack trace, essentially showing all the sequence of methods where the problem happened. So in our code, what we actually saw, the exception occurred in the main method. Since there wasn't any exception handling in place, we'll talk about that in a minute, it exits the program and transfers control back to the Java virtual machine, which then prints out the stack trace. The others, these methods all in red, this is the whole stack trace from inside the scanner class. So we imported the scanner class so we can use it, but we don't actually have it visible in our program. But we can see, yeah, when we tried to get this next int value, there were a series of method calls there where the problem happened. Okay, so short version, why exceptions make programs crash. So we know a Java program is a sequence of nested method calls, starting from when the Java virtual machine initially calls the main method to get the application running. So if an application occurs in some method X and isn't handled, then X returns the execution flow to the method that called it. So we can do that in our code here. We can create a static method. We'll say static int get input, and we'll put this here. We'll say return number. Okay, and here we'll, instead of that number, we'll do the method call get input. Okay, so what's going to happen? Our main method is going to call get input. Get input will do that same stuff we had before where it asks for a number. If this part doesn't work, if I enter in 3.1, won't have anything to return. So enter integer 3.1, boom. Now we see the sequence of nested method calls, right? So main method called get input, that's actually where the exception happened in our code. And then get input didn't have any mechanism to handle the exception, so it popped out of that method and went back to the main method. Main method didn't have any mechanism to handle the exception, so it transferred control over to the Java virtual machine, which again prints out this stack trace of all the method calls that were going on when the exception actually happened. Okay, but of course you mostly don't want to do that. Mostly you want to actually catch exceptions when they happen. So basic mechanism for that is the try-catch block. So the try-catch block, first there's a try block. In the try block, you have any statements that might conceivably throw an exception. For example, this scanner.nextInt, which has been throwing the input mismatch exceptions. Then you have a catch block. And the catch block is for a particular exception type. So if this kind of exception occurs in the try block, the execution flow will jump to the catch block. Okay, so we can do that in our code. Let's do a very simple one, try catch. So we'll embed this in a try block. And well, we'll do it this way. Okay, and then we'll catch this. We'll catch our input mismatch exception, which we'll call E. Okay, I have to import that because that's part of what scanner has. And the other thing, I have to make sure I return a number. So here, I'm going to set this. I'm going to say input int number equals 0. Now the problem with this, right, which we'll see in a second, but for now we can see that this catches the exception. Okay, so if I run this and the exception gets caught, system.out.println, you must enter a valid int value. Okay, so let's run this. And now if I do 3.1, the program doesn't fail, it doesn't crash, but it does something weird, right? It says it goes with this default value, which of course could be a valid one. So what I really want to do is something like Boolean has valid input equals false, and then I'll embed this in a do while. So I'll say do all this while not has valid input. Okay, so I'm going to take this and bring it down a bit. And this, let's see, for the rest of this we're going to all shift right. Okay, so if we have a valid one, we'll do this has valid input equals true. Okay, so now what I'm going to do, I go into this do while loop. I'm going to try to get the input. As long as the input isn't valid, right? It's going to hit this statement and it's going to throw the input mismatch exception, and then it's going to exit the do while loop and say, oh, has valid input is still false, so it's going to repeat the loop again. However, if the input is valid, then it proceeds on. This has valid input Boolean will be set to true, and I skip the catch block, and then when I do this test, I'll say not true is false, and so I'll skip the do block, and then I'll just return the value that got entered. Right? So now I can repeatedly enter invalid one, 3.1, 3.2, 3.3. If I finally enter 0, okay, I entered 0. So this sort of thing with while loops and exception handling is a good way to keep your program running up until the point where a user actually enters a valid input. Obviously, it's useful for things like password protected entry, things like that. Okay. So the general syntax for this, if you have statements that might cause an exception, so up here in the try block, we have a series of end statements that might conceivably throw an exception. And suppose that an exception happens at statement 3 here. Well, what will happen at that point, the execution flow will jump out of the try block, won't execute any more in there, and it'll proceed on to the catch block. It'll execute all the statements in the catch block for that exception type, and then afterwards it'll continue on to the next statement, whatever occurs after. So just like it happens here, if an exception happens here, the execution flow jumps to the catch block, and then after it does everything in the catch block, it proceeds onward. The next thing will be to test this while test. On the other hand, if no exception happens, then the execution flow goes through the entire try block, then skips over the catch block, and does whatever it needs to do. So if I go through this entire block, I reach the end, I set has valid input to true, I skip over the catch block, and then I do this while test. Since has valid input is true, not true is going to be false, so I don't repeat the loop, so I proceed on to return the value that the user entered. Okay. Other stuff. There's a couple methods with the exception class that you can print message. So if somebody creates a message that you want to send along some sort of diagnostic information, you can print that out. You can also do print stack trace, and print stack trace is just the same sort of dump of all the nested method calls that you see when the program actually crashes. So, for example, I could do this, right? If the exception happens, I do this. I can print out that information. Okay, I could say get the message, get the stack trace. So when we run this, if I enter 3.1, it shows this, right? It shows this stuff. It still says I have to enter a valid value. It can do some stuff. I didn't pass along any message, so that shows up at null. This is the stack trace here, and you can see there's a little bit of weird overlap where it asks me to enter the integer again. So if I do it again, 3, entered 3. So yeah, one of the things you'll see is that stuff doesn't always get printed out to the console in the sequence that makes sense. Excuse me. Okay. Now, you can have multiple catch blocks, for example, if your try block can throw multiple kinds of exceptions. So for example, if you have some statements in here that could throw an input mismatch exception, yeah, this catch block will catch that one. If it could throw an array index out of bounds exception, then it'll catch that catch block will be where the execution flow happens. So we'll look at some sample flows here. So on the left, there's a try block, again, end statements in the try block, and assume an exception occurs at statement 3. Let's assume that the exception type corresponds to this catch block. We have M catch blocks, so the specific exception type that happens is the one that's caught by block 3. It executes everything in block 3, and then it skips over the other catch blocks to go to whatever the next statement is. On the other hand, if there is no exception, just like before, execute everything in the try block, skip over all the catch blocks, and then proceed with the next statement afterward. Now, there is one tricky part about catching exceptions. Since you only catch one, you can do this. So, exception is the superclass to all the various exception types we're going to cover. What will happen in this case, if I have an exception catch block that catches this superclass, well, every input mismatch exception is actually a subclass of exception, and so every input mismatch exception is a kind of exception. So what's going to happen, even if an input mismatch exception happens here, it's always going to get caught by this catch block. And so this stretch here becomes unreachable code. If you look at the error there, it says unreachable catch block. So big picture on this, anytime you have some superclass, you want to put that superclass last. So if an input mismatch exception happens in here, sure, the execution flow will jump to this catch block. This is the block that'll handle it. If a different kind of exception happens, right, it'll get caught by this catch block. Okay. One last thing, the finally block. So in some cases, you want to have an action happen regardless of whether an exception is thrown or not. So those statements that have to be executed regardless of whether exceptions happen, put in the finally block. Now interestingly, the finally block has no effect on code. So for example, if I put in here some simple statement, system.out.println, thank you for your input. This is going to execute, right? Once I'm done with all this try catch stuff and exit out of the loop, that's going to happen. Okay, I'll put it in here so it actually makes more sense. So I'll say thank you for your input. On the other hand, what's going to happen? So this is all. Well, what do we want to do? Yeah, it's fine. This will be fine for now. If I run it, it's always gonna run. Okay, so I enter in 3. Thank you for your input. You entered 3. On the other hand, even if I end up putting in an invalid input, it's still going to thank me for it, which is a little screwy, but that's all right. Now, if I put this same statement in a finally block, likewise, it's always going to execute, regardless of whether an exception happens or not. So if I enter the integer 3, still says the same thing. If I enter in an invalid input, 3.1. Same thing, right? It asks again, then if I do 2, that's fine. Okay, so what's the point of the finally block? Since it does always execute, it doesn't have any effect at all on code execution. Code that's in a finally block always gets executed after the try-catch sequence. Code that's not in a finally block always gets executed after the try-catch sequence. Reason why it's there, is basically for code reuse. If you have a programming team that wants to cut some chunk of code out of one program and put it in another one, it's good to see that the try, catch, finally sequence is part of a complete logical unit, so that you don't end up wondering, oh, these particular statements here, are these part of this test or not? So that's the point. It's useful for code reuse. And the execution flow here, again, suppose an exception happens in our try-catch block, happens here, jumps ahead to the corresponding catch block, then afterwards it executes all the statements in the finally block. Okay? If no exception happens, all the statements in the try block get executed, the execution flow jumps to the finally block, and then again proceeds onward with the next statement. So regardless of whether an exception happens or not, everything in the finally block gets executed. So again, finally block has no effect on how the program actually runs. It's more for administrative stuff, code reuse. Okay, next up, propagating exceptions. What we've covered up till now is exceptions that are handled in the method where they occur. But we don't necessarily have to do that. There's other ways we can do it. One possibility is we can throw the exception back to the place where it happened, right? We can say, we're not going to deal with this exception locally in our method. We're going to try to make you handle it. So I can do another method here. I'll call it getInput2. So static void getInput2. And for this one, I'll get a double, let's say. Okay, so it's basically going to be the same structure, except I'm not going to have this all in a try-catch block. Okay, so we'll do our number is instead going to be a double. Okay, and we'll ask has valid input equals false. We're not going to do it in a try block. Okay, we're just going to take this out. All right, and we don't have any of that stuff. Okay, we'll do the thank you for your input though. What do we have here? Return number, static double. Okay, so this one, how do we handle the exception? Well, even if we don't put anything in here to deal with the exception, this program is going to have to deal with it. So again, if we call this one, right, we can call getInput2, get a double, and if an exception happens here, we're going to have all of our usual bad consequences. So one thing we can do is say, hey, this method's going to throw something. Okay, so we can put that in the method header. Throws input mismatch exception. Okay, now there we're just being very explicit to say this method can throw an exception. Well, that's fine. It doesn't really change how the program runs though. So we'll do that. That's the general way to do it. So enter an integer, and for the, we don't want to do an integer, do we? We want to do a floating point number. Let's do that. Okay, so integer 3, floating point number, make me. Okay, and we get our input mismatch exception. Now, at that point, right, it still has to be handled here. So what's the point of this? Well, we're just making a note for anybody who reads the program that, hey, this method could throw an input mismatch exception, right? But we're not forcing anybody to do it, because input mismatch exceptions are what are called runtime exceptions. They're only checked while the program is running. However, if we use what's called a checked exception, like the exception class, then we get an error up here. If we look at this, we say unhandled exception type exception. So there's a difference. This exception type, we actually, when we do the method call, we have to do this. You have to put it in the exception handling structure. Okay, and then we're okay. Then the error goes away. Okay, we'll talk more about runtime and checked exceptions in a moment. But the basic idea of propagated exceptions, you can specifically say, hey, this method could throw an exception. Look out. You're giving programmers fair warning. Okay. Now, another way to do it is you can do a test with a different kind of exception. So we could say here different kinds. So let's do different kinds of exceptions. So we'll say, what could we want to do here? If we enter a floating point number. So let's say somebody enters in a number. What do we want to do here? Let's say enter in a floating point number between 0 and 1. Okay, so if somebody does that, then we can get the next int, right? Could still be a valid number, but we could say this. If number is less than 0.0 or number is greater than 1.0, throw new exception. Okay, and we could throw an exception. So here we don't even need to put it in the header. We could just say, hey, look out, this method, right, doesn't like it. I have to keep it in there. Oh, the scanner, unhandled exception, type exception. So if you have your method throw an exception, if you specifically say, yeah, this can throw an exception, it has to be handled. It has to be mentioned here because I'm not handling it here in the method, and then I have to specify in the header. The syntax is a little weird for this. So once again, with this kind of mechanism, if I don't have this in a try-catch block, right, I get the error. So I have to say, this has to handle the exception. Okay. Now, any method can throw an exception, but there's two ways it can happen. It can throw it directly because the method does it, it generates the exception itself. Then it's called an exception thrower. If the method throws it indirectly because a method called another method, that method generated the exception, and then the method that called it actually passed on the exception, that's indirect throwing. So, one second, the dog's going insane. Okay, so we're back. So, methods can throw exceptions either directly or indirectly. In either case, the method's called an exception thrower. Every method that throws an exception has to either handle it locally or pass it on. So if it handles it itself, it's an exception catcher. If it passes it on to the method that called it, it becomes a propagator. So here's a diagram of this. So we have four methods. A calls B, B calls C, C calls D. Now, D can actually generate an exception somehow. Okay? When it generates an exception, it doesn't have any place to handle it. So D is not a catcher for that exception. It's a propagator. So if the exception happens, it kicks it back to C. It says, C, you called me, you deal with this. Well, C doesn't have any exception handling mechanism in there either. So C is not going to catch it. So C does the same thing. C kicks it back to B, the method that called it. Now B does have an exception handling mechanism in here, right? It calls C in the try block. So if C throws the exception will get handled in this catch block. And then E is never going to see it. So the rule is always exceptions get handled as close to the method where they occur as possible. The basic reason for that is if you didn't, then any time an exception happened, the program would crash all the way down to the Java virtual machine and end. Instead, right, you want as much of the program as possible to keep on running. The way you do that is that you never get close to the main method if you can help it. Because remember, once the main method is done, then the program is over. Okay. Basic exception types. So there's a tree of this. All the thrown exceptions, all the exceptions are instances of what's called the throwable class. There's two main branches. Error is basically for serious hardware-related issues. It's like your system is all messed up and you need to check something out. So that's what errors and in particular assertion errors are for. Exceptions, on the other hand, are generally things, yeah, something went wrong, somebody entered the wrong type of input or some device failed or something, but not usually as critically serious as an error. The type of things that are generally occurred in errors are things that involve, say, memory failure, for example. Okay, so let's give a couple examples. The basic ones that we know, null pointer exception, you've probably seen that. If you try to access an attribute or call a method of an object, but the object hasn't been created yet, the object is null, you get a null pointer exception. Another one that we've seen just a minute ago is input mismatch exception. There's array index out of bounds exception for the case where you try to access an invalid array index, and IO exception for input-output exception. We'll see that for our file input-output in our next lecture. Okay, the difference between checked and runtime exception. So there's two kinds. A checked exception is an exception that gets checked at compile time. So when when your IDE is trying to compile your source code to make it runnable on your machine, if there's a checked exception that can happen, then there has to be an exception handling mechanism in place for that. All the other ones are unchecked or runtime exceptions. Runtime exceptions only get checked when the program is actually running, so you can compile it without necessarily having those exceptions handled. And most exceptions are runtime exceptions, but there's a few key ones that are checked. So the input-output exception, for example, that's one. The idea there is if you have some enterprise-scale Java application running, you don't want the whole thing to fail because, say, a hard disk went down. So the basic idea is if the potential problem is very serious, Java wants to make sure that you have exception handling in place for it. But for runtime exceptions, which include things like array index out of bounds exceptions, it would be a gigantic pain in the ass if every time you referenced an array, you would have to do it in a try-catch sequence. Or for example, if every time you referenced an object or called an object method, you would have to cover a null pointer exception. That would be a colossal pain in the ass, especially since the null pointer exception or the array index out of bounds exception itself generates an exception object, and then you would have to embed even that part of it in a try-catch block. So kind of crazy. That's basically why they say, yeah, some things are really critical in practice. We're going to make those checked exceptions. Other things, yeah, stuff could go wrong, but we're going to count on the programmers to fix that. Okay, so different handling rules. All this is basically a recap of what we've covered. So if you have a checked exception, right, one that definitely has to be handled, there's two ways it can happen. Number one, if you call this method do work can throw an exception. An exception is a checked method type. If we call the do work, we do it in a try-catch block. Thus, any exception that gets generated, gets thrown by do work, gets caught in this block. Or we can say that this method is in fact going to throw the exception. So we say this method, yeah, it's going to call do work might generate an exception, but if that happens, we're just going to throw it. We're going to pass it on. We're not going to deal with it locally, but any method that calls this method will have to handle that exception, or it's self-propagated. Okay, runtime exceptions, similar, but there's more flexibility. You don't have to cover stuff. So one possibility, we have this method do work that can throw a runtime exception. That's fine. If we call it, of course, we can embed it in a try-catch sequence, and then this method will catch any exception it generates. Or another thing we can do is we can specify that this method, which calls do work, doesn't handle it locally. We can say in the header, it throws that runtime exception. Okay, but that's what's going to happen anyway. We don't actually need to put that in the method header. Or, this is the most common style, we just say, you know what, this method's going to call do work could throw a runtime exception, but we're not even going to mention it. We're just going to say, yeah, it could do it. If any method calls me, well, you could have a runtime exception happen. The reason is, again, runtime exceptions, basically, a lot of them, you're just going to assume that the programmers wrote the code correctly, and that it's not going to be a critical problem. Okay, another thing you can do, you can make subclasses of exception. Typical reason why you would do that is to include special messages or other diagnostic information. You could include a special error message that's going to get printed out to the user. Okay, assertions. Assertions are basically a way of testing that your program is running correctly, the way it should be. Basic syntax for it is assert and then some Boolean expression. And this Boolean expression is either going to be true if the code is working correctly or false if there is some kind of serious failure. And if this assertion statement results in false, right, the Boolean expression is false, it's automatically going to throw an assertion error, which is basically, you know, it's an error, but it works the same way as exception does with try-catch handling. So, for example, if you have a bank account and you're depositing some money in it, you're depositing an amount of money, it's a metaphysical certitude that your ending balance should be greater than your old balance, right? So we assign a new double called old balance. we give it the value of our original balance, we increase our current balance by whatever amount we've deposited, and then we do an assertion to test that the balance is greater than the old balance. Right? If that's true, then everything's fine. We added some money to our account, the balance went up, all is well. If not, it is a very serious problem that needs to be addressed. Same thing with withdraw over here, that we have an old balance. Again, we assign balance to it. We deduct the amount from balance, and then we do an assertion to verify that the current balance is less than our old balance. Okay. You can also do it with a colon and then a message afterwards, so you can send a message about what went wrong. For example, assert balance is greater than old balance, and as a message you could put in something like this: balance did not increase after deposit, right? That would be a quick diagnostic error message for the programmers to process. Okay, last thing, if you want to run programs with assertions, basically the way you do that, you go to the Run Configuration menu, and in the virtual machine, the VM arguments, enter the argument EA. So for this exceptions, if I wanted to do it, I could do Run Configurations, and then over here in the arguments block, virtual machine arguments, EA for enable assertions. Okay, very simple. Or if I want to do it for all my programs, I could set it as a default option. So I go to Windows, Preferences, Java, Install JREs. Then I set -EA to the default virtual machine arguments. Okay, so Window, Preferences, Java, Install JREs, execution environments. Let's do this one. I'm going to look at this one, which is the current one I'm doing now. Let's see. There we go. So this one, I'm going to go to Edit, and I set up virtual machine arguments. There it is, -EA. So all of the programs that I run with this, they're going to have assertions enabled. Okay, so for example, I could do at the very start, assert true. Okay, and that assertion should be true, and the program should run fine, and it does. 3.1, whoop, no, 0.9. Okay, wonderful. Everything is, what happened there? Oh, because I didn't enter a valid thing. I threw that, I threw that input mismatch exception. Okay, but let's do this. We're just trying to do assertions here. So let's do another one, assert false, and then I'll do try. Right, I'll put in a try block. Obviously, if I have a try, assert false, and then catch, and I'll do system.out.println assertion false. Okay, and I'll do here assertion error E. Okay, so we run this, and then I'm going to get the assertion error when I start right off the bat. Boom, assertion false. Okay, wonderful. Okay, let's go through one last time to make sure 0.9. And not doing that. Let's see. That's a little strange. Am I not printing the value? What's going on here? It's a little strange. Okay. Anyway, that's the stuff you need to know. I'm going to play around with this code a little bit and then get it posted up there.